All right, let's move on a little bit into more exciting part of database design. And so now you have got the basics and the foundations to start learning about designing databases. There's a lot more involved, and what I want to talk about now is a kind of notation. Now you know the terminology. Now I want to show you notations that you can use, diagrams, etc., to represent your idea of a database that consists of many tables, many relationships, etc. So use a data modeling tool to represent the data for an organization, for a problem that you want to solve. This data model that you will learn in this subject is called entity relationship modeling, or entity relationship data model. And you'll be building using entity relationship notations to build databases. The notation is fairly easy. Because when you think about it, we said a database, in a database we store data in tables, and each table is representing an entity, an object, an item, a person, and these tables will have relationship with each other. And the reason we store relationships between tables because we can get more information now through relationships that you will see. That doesn't exist in a table alone. If you just have a table that has got the details of an object, an item, just a student or a staff in that example that you saw, and a branch that has got the details of the branch, then we would not know which staff works in which branch unless we establish the relationship through storing the branch number with the table of staff. Then we know which staff works in which branch because we know the branch number, and then from the branch number in the table of staff we can link to a row of table in the table branch and find the details of that branch, the full details. So you can get more information if you store not only the entity data in tables, but also relationships between these entities. So a table is really an entity, is a relation. An entity is something, an object, an item, a person that we are interested to store data about for our own organization. And in this university, for example, the persons are students, staff. The objects are, for example, subjects, buildings, I don't know, the other things. So on an ER diagram, what you will see on an entity relationship diagram, of course, you have to be able to represent each entity or each table and the relationship between the tables. Also, you may like to show the attributes of each table. An entity type is a group of objects with the same property that have got an independent existence. So basically an object, an item, something that you are storing data about. That's called an entity. And each entity is unique, so for each entity we have got only one table. So some entities you can see, you can feel, you can touch. Some entities exist as concepts. For example, the staff, property, the house, customer are entities that have got physical existence. You can go and touch the building, building number, house number. Parts of a that you're selling for the part of vehicles, etc. Supplier has got physical existence. Normally, I know there are lots of suppliers that are online. And product products or things that you can touch, hopefully. You may say, and I've got all this discussion with all your very clever people. I say, music files or products with why these days, so you can't touch it. I think if you put it on a USB, you can touch it. But you're right, but the data exists. But so the entities could be physical, have physical existence, or something conceptual, a concept in our mind. For example, a sale. It's not something that you can touch, but it's something that exists. When you purchase something, the sale is done. Work experience is you can touch it, but exists. Viewing or inspection of a house is another entity and that you may be interested to store details about. So if you have a real estate agency and you store the details about your customers, properties that you've got for rent, properties that you've got for sale, and then on weekends you've got open inspections and customers coming through, and you want to store the details of every customer that came through and the comments they made, So you can store in an entity called viewing. In a table inspection, you could put in the time and date of each inspection for each property. So the entities could be something physical that you can touch or something conceptual. So to represent entities, we draw a box and put the name of the entity right in the middle, and that's what you're going to use for in this subject. So this is called the entities are represented as a box with the name of the entity in there. So if you look at here, we've got two entities here on this diagram: entity staff and entity branch. Just the entities, no relationships now here. Now, if you want to say that two entities or three entities or five entities have got a relationship with each other, you have to have some representations that show that. So relationship is a sort of associations between the two entities that you establish through foreign keys. And this is a diagram that your book uses to give a bit of details, and actually I just use it here because you read the book. And so here, the oval has got no meaning. It's just representations that they use to explain something. This is not part of the ER diagram. So we're just saying, for example, if you think of all the branches, you've got, in this case, they just put two details of two branches, B003 and B007. Then you can see that the staff SG37 and SG14 works in, they both work in branch B003, and then in B007 you've got a staff SA9. Sorry, SA9. And the relationship between these two are that, for example, the branch has a staff. So each relationship has got a name. So we associate a name on our diagram for each relationship. Here is again the data. So for example, the branch has a staff, and there's a relationship between branch and the staff, and it's just represented through drawing a line from entity branch to entity staff. The whole idea of in notation has to be unique representations of every item that you would use. In this case, entities and relationships. But it has to be simple too, and that's what the beauty of this ER diagram is. So if I show you now this diagram, from now on, you will be able to tell me, look, there are two entities in this database, and the branch and the staff it's called relationship, and the name of the relationship is called has. So you could have many entities involved with many other entities. So it's not necessary that you've got a relationship only between two entities. You could have a relationship between 3 entities, or 6 entities, or 10 entities, whatever you want, depending on the problem you're solving. But there are some names associated to them, so binary, ternary, quaternary, and you can figure out what it is, but you don't have to memorize any of them. So here is a relationship between two entities from the example in your textbook. So let's say we have got the real estate agency, and one of our tables is called private owner, and in this table we store the details of all the owners of our properties that we manage or we are going to sell. And then we have got the another entity called property for rent, and in that we've got the details of all the properties that we have available for rent. So you can see there is a relationship between the owner and the property, so the owner owns the property, so, and that's why we store the relationship in there. So you just draw a line. I'll show you the tables later on. So here is another example. Just take it easy and just look and enjoy what's happening here. We've got three tables: staff, branch, and client. And there's a relationship. For example, in this case, the staff registers a client at a branch. So that means when we store the details of each client that come to a branch, we just put in the branch number in which the client is enrolling or registering, and also we store the details of the person that entered the data, the staff number. Yeah.
I can tell which direction the reading is going on that. It could be branch registers and stuff.
Very good questions. You know, the question is, how do you know which way to read? You know, in this case, I tell you the staff registered a client at the branch. You could say branch registers client staff. I don't know. This depends on the problem. But you can show it. We'll go into more details. And the reason I know it because it's written in the corner of this image. That's why I read it for you. But this is really coming from the problem. That's the problem of specification that defines which way these relationships go. In here again, you've got, all I want you to understand is that there are four attributes: solicitor, financial institution, bid, and buyer. They're the four entities. I don't know what the attributes are, you know, same as you. This just showed me the entities and the relationships. That's it. But I can see, you know, now we can communicate. If I show you this diagram and you say, you know, how many entities are there, which entity has got a relationship with which entity, you can tell me. And that's very interesting. We don't need to look at the data to figure out no things. We can now conceptualize and build a model, and then from this model build a table. There are many type of relationships that you could have. So one of them is called the recursive relationship, and that's a very interesting one. Very rarely you see them. For example, you can say an entity having a relationship with itself. So, for example, a member of a staff supervises the other member of a staff. So, just the relationship is from a staff to a staff, and that's what's called recursive relationship. And you'll see how to store represented in actual table with the data later on. So here again, for you. Maybe that helps. The relationships between the two entities could be in several ways. For example, branch has a staff as one relationship, and the staff manages branch as another relationship. So there's two relationships here, two different ones. They're two different ones.